come to know first multivibrator. Man already we say that multi means many stages. Multi means many. Vibrations means oscillation. Many oscillations producing got multivibrator. Multivibrators are three types. One is stable multivibrator. Second one is monostable multivibrator. Third one is bistable multivibrator. In stable multivibrator, the name itself indicates stable. The name itself indicates having the no stable state. Does not having any stable state. The two states are quasi-stable states. That means there is no permanent state in a stable multivibrator. Always the state of the changes continuously until the power supply is on. That means every time what you are given the time period, the automatically the switches means Q2 on, Q2 off, Q2 on, Q2 like that, the continuously changes. That name is also called as stable multivibrator. It is also called as square wave generator, also called as free running multivibrator. Sometimes it is also called as voltage to frequency converter. Why? Because the voltage applied at the base of the that transistor base that R1 R2 changes the voltage. Then the charging voltage also capacitor changes. That's why the name given as also voltage to frequency converter. General applications are used for generating the square waves. Now come to second one is monostable multivibrator. The mono means single. Therefore, the name itself indicates that it having the one stable state and one quasi-stable state. When switch on the power supply, once we switch on the power supply, one transistor is on, other transistor is off. Which transistor is on, which transistor is off, depending upon the coupling. Collector of the one transistor is connected to the base of the another transistor. Suppose collector of the Q1 transistor is connected to base of the Q2 transistor to capacitor. Then the Q2 is on. If collector of Q1 is collector of Q2 is connected to base of Q1 through capacitor, then Q1 is on. Therefore, depending upon the AC couple, that means which collector and base is connected capacitor, that capacitor is transistor is on, other transistor is off. That means once you can apply, once it is switched on the power supply, the monostable multivibrator is in the stable state condition. Previously, we have seen that base of collector of Q1, base of Q2 is connected capacitor, that is AC coupled, and collector of Q2 and base of Q1 is connected resistor, that is called DC coupled. In this circuit, the Q1 is off, Q2 is on. Once you can switch on the power supply, the transistor is on stable state condition. In the stable state condition, Q2 is on, Q1 is off. Until trigger pulse is not applied, the monostable multivibrator always in stable state condition. Now, when I apply the trigger pulse is always symmetrical trigger pulse you are going to apply. Always symmetrical trigger pulse you are going to apply. Symmetrical trigger pulse may be applied at the base of the Q1 or base of the Q2 or collector of the Q1 or collector of the Q2. Depending on the requirement, you can connect anywhere. But which transistor is on, the corresponding base should be negative. Which transistor is off, the corresponding base should be positive. According to that, you are going to apply the trigger pulse. Once you can apply the trigger pulse, the position of the transistor changes. Now Q2 is off, Q1 is on. Q2 is off, Q1 is on. Now the capacitor connected between collector of Q1 and base of Q2 charging through R resistor, through VCC. Enthavaraku charge avutundi? VCC variki charge avutundandi. Once you apply the negative trigger, once applying the triggering pulse, the voltage across capacitor suddenly changes to VBB stat minus VCC. That is approximately equal to minus VCC. Capacitor voltage becomes minus VCC. Once Q1 is on, the capacitor starts to charging from VCC. Minus VCC nunchi you can charging from VCC. Minus VCC decreasing. Still, that means if it is like this, This is at base of this is initial voltage is once you are trigger previously it is VC is at base of the nothing but collector of the transistor, that one. This is once you can apply the base of the Q2 becomes like this and the capacitor charging towards VCC. Actually charge అవ్వాలండి, VCC వరకు charge అవ్వాలి, VCC వరకు charge అవ్వాలి. But when it is reaches to VCE sat, what happened? The capacitor voltage reaches to VBE sat, the Q2 is on and Q1 is off. Then once again that is entering into the stable state. This state is called quasi-stable state. This state is called quasi-stable state. The charging of capacitor, how much time is charging? The total time is nothing but quasi-stable state. That state time is depending upon selection of R and C values. Selection of depending upon the R and C values. The T is equal to 0.69 R and C. Therefore, sometimes if you are not applying the VCC, the another formula is also T is equal to RC into natural logarithm of 1 plus VCC by V. If V is equal to VCC, then 0.69 RC. If VC not equal to VCC, depending upon the voltage V, the time period is dependent. Once capacitor reaches to VB sat, then once again entering into the stable state. Once again the monostable multivibrator entering the stable state is still same in the stable state only, does not change until we are going to apply trigger pulse. When you are applying the trigger pulse only, that value is changes. Therefore, this applications, this another names are monostable, another names are voltage to time converter అనొచ్చు, voltage to time converter అనొచ్చు, లేకపోతే one shot అనొచ్చు, లేకపోతే rectangular wave pulse generator అనొచ్చు, depending upon the applications. Delay circuits అనొచ్చు, because how much time after delay the another circuit is trigger. That's why it is also used for delay circuit. Monostable multivibrator is also used for delay circuits. Come to bistable multivibrator. In bistable multivibrator, the two states are permanent states. The two states are stable states and there is no quasi-stable state. In bistable multivibrator, there is no quasi-stable state. The two states are stable states only. Once switch on the power supply, the monostable multivibrator in the one of the stable state. Once switch on the power supply, once you can switch on the power supply, the bistable multivibrator is in one of the stable state. Either maybe Q1 is on, Q2 is off, otherwise Q1 is on, Q2 off, depending upon the parameters, all those parameters required. Therefore, once you can on the switch on the power supply, the bistable multivibrator is one of the stable state. Now, it remains same state until you are not applying any trigger pulse. Now, I am going to apply trigger pulse. Where you apply the trigger pulse, which type of trigger pulse I will tell you later. I am applying the trigger pulse. What happens? To change the state from one stable state to another stable state. Previously, let us assume Q2 is on, Q1 is off. Now I am going to apply trigger pulse. Q1 is on, Q2 is off. Now, once you can apply the trigger pulse, what happened? The stable state, first stable state is converted into the second stable state. Still, that remains in the same state. There is no change in that until one more trigger pulse is applied. Means when you are applying the trigger pulse, that means let us assume this is the waveform. I am assuming this is the waveform. This is voltage across Q1 and let us assume this is voltage across V2. This is I am not applying any trigger pulse. With not applying any trigger pulse, let us assume this is Q1 is high, Q2 is low. Q2 is low. Low on suppose. This is equal to, this is nothing but, this is across VC1. This is across VC1. This is across VC2. Across VC2. Until I am not applying any trigger pulse, the state is remains same state. One I am either positive or negative, I will tell you later. I am applying the trigger pulse here. I am applying the trigger pulse here. positive trigger is applied, which one transistor is off? There you can apply. I am applying the base of the Q1. What happens? This voltage becomes low, 0, and this becomes on. This is on. Now until trigger pulse is not applied, the state remains continuously same state, stable state. When I am applying trigger pulse here, depending upon either whatever my thing, once again that state is changes here. Then trigger pulse applied, the state of change across here. Until trigger pulse is not applied, same state is continuous. This is nothing but bistable multivibrator. Bistable nothing but both states are stable states. There is no quasi-stable state. Means quasi means sometime is in that state. Sometimes they will stay in that state. That's why the name given as quasi-stable state. In bistable multivibrator, there is no such type of state. That's why in this we are in the two states are stable state. Now come to see here. Therefore, there are two types of multivibrator. The bistable multivibrator. One is fixed bias, that is about collector coupled understand. That is also collector coupled. Fixed bias collector coupled multivibrator and self bias collector coupled multivibrator. Simply it is called fixed bias bistable multivibrator. Another one is self biased bistable multivibrator. Now come to here. In fixed means we are going to apply some fixed voltage of across base of this one through resistor. I am applying the fixed voltage here minus VBB. In the figure shows fixed bias collector to base coupling. Simply it is called fixed bias collector coupling. Bistable multivibrator using NPN transistor. See here Q2. See here Q2 collector of Q2 is coupled to the base of the Q1 through R1. And similarly, base collector of the Q1 is coupled to the base of the Q2 to is R2. Both are DC coupled only. There is no capacitor. That's why all are DC coupled only. There is no AC coupling. That's why there is no quasi-stable state. Therefore, there is no any capacitor in between base and collector of the two transistors. That's why the two states are stable states only. Okay, now. There we are applying the VBB voltage through R2, Q1, Q2 are going to apply. This is nothing but 1 minute, 10 minutes తర్వాత అయిపోతే మళ్ళీ ఆన్ చేయండి. ఎందుకంటే 40 minutes కంటే ఎక్కువ రాదు. మీరు వచ్చేసరికి లేట్ అయిపోయింది. మళ్ళీ ఐఎమ్ గోయింగ్ టు రిపీట్ వన్స్ అగైన్. ఓకేనా? 10 minutes తర్వాత అయిపోతుంది. ఫస్ట్ లిసన్. దిస్ ఈజ్ నథింగ్ బట్ మల్టీ. కమ్ టు ఫస్ట్. లెట్ అస్యూమ్ చాయిస్ ఇవ్వచ్చు అండి. Once I am the switch on the power supply, both transistors try to conduct, both transistors Q1 and Q2, both transistors try to conduct, but due to some reasons, maybe collector one, some reasons I1 may be current more or I2 current be more. Due to some reason, due to some internal parameters, both transistors Q1 and Q2 try to conduct. Suppose two transistors conducting. But maybe one collector I1 current may be more or I2 current may be more. Slight variations are there. Let us assume this current is high. Let us assume this current is high. This I1 is current is increases. Let us assume I1 current is increases. Because of this is conducting heavily, I1 current is increases. When I1 current increases, here I1 current is increases. The voltage across drop, this one is this voltage drop across increases. Why? Because this drop is nothing but RC into I1. As the current I1 goes on increases, drop across here goes on increases. When drop across increases, what happened? Here voltage is nothing but VCC minus, here voltage is nothing but VCC minus, here voltage is nothing but VCC minus RC I1. This is nothing but RC I1. This is RC I1. What happens as the current I1 goes on increases? What happens? The voltage drop across collector of the decreases. Now this voltage is directly coupled to the base of the Q1, base of the Q2. This voltage, how much voltage present directly coupled to the here. Therefore, what happens? As the collector voltage here decreases, the base current is decreases. The current flowing to this one is IB2. What happens? The current IB2 goes on decreases. IB2 goes on decreases. IB2 what happens? This is decreases. When it is decreases, I2 current is also decreases. Why? Because the conduction is decreases. I2 also decreases. When I2 is decreases, what happens? Here voltage is also same. VCC minus RC into I2. Here voltage is VC2 is nothing but VCC minus RC into I2. But what happens? I2 is decreases. The voltage across collector of the Q2 is increases. The voltage across collector of the Q2 is increases. Once it is voltage increases, once again base current is goes on increases. Once base current increases, this collector current is also goes on increases. This process is continuous until the Q1 is cut off. The Q1 is on state because of this is heavily conducting. This is off. This is off. Why? Because this collector current, this I1 is goes on increases. The drop is goes on decreases. This drop is goes on decreases. Therefore, this voltage is goes on decreases. This is into on state. This is Q1 is on, Q2 off, Q2 off. You can explain another way. Previously, you can assume I2 is higher than the Q1. Just therefore, this is off, this is on. We can assume any one current is slightly greater than that. You can assume once the switch on the power supply, same condition is repeated. This is nothing but, therefore, this is in stable state. Therefore, once after certain time, because it will take fraction of time to entering into the saturation region and cut off. Initially, once you can on the power supply, both transistors try to conduct. Therefore, due to internal parameters, all those parameters, one current may be high, one current may be less. Which current is high? That collector is goes into on state, other collector goes into off state. This is nothing but one state of that one. Once it is this one condition, what happens? See nothing but another one. See here. When switch on the power supply, both transistors trying to conduct. This is what I explained. I once again going to repeat. When the switch on the power supply, both transistors try to conduct. Let Q1 transistor is conducting heavily when compared to transistor Q2. అదే చెప్పానండి. ఇప్పుడు వాట్ ఐ ఎక్స్ప్లెయిన్ సేమ్ థింగ్. మీరు ఇలా కూడా రాసుకో. Q2 transistor is conducting heavily when compared to Q1 transistor. Choice yours. ఇలానే రాయాలని ఏం లేదండి. You can write according to your choice. For this condition, Q1 increases. When Q1 increases, due to this, RC1 increases. Therefore, voltage across Q1, that is nothing but VC1 decreases because VC1 is equal to VCC minus RC into R1. As the I1 goes on increases, VC1 is decreases because of decreasing of base voltage of Q2. Because of decreasing of base voltage of Q2. Why? Because collector voltage of VC1 is nothing but base voltage of Q2. Therefore, the conduction of the transistor goes on decreases. And hence, what happens? The current I2 decreases due to decreases. Due to this, the top voltage across Q2, what happens? Increases. Why? Because Q1 increases. Why? Because VC2 is equal to, so the voltage drop across. This is Q2 amma. Sorry, this is Q2. Don't write Q1. This is Q2. This is RC2. What happens? The voltage increases at VC2. Therefore, this process is continuous until low Yavaru, Abdul, Abhilash. Okay, na. Therefore, this process repeat until Q1 is entering into the saturation region and Q2 is entering into the cutoff region. Therefore, the bistable multivibrator is in one of the stable state. Once it reaches that condition, that means either Q1 is entering into the saturation region, Q2 is entering into the cutoff region. Therefore, the multivibrator is in the one of the stable state condition. And the stable state condition, VB1 ఎలా ఉంటుంది? Because VB1 అనేది ట్రాన్సిస్టర్ Q1 is on. Q1 ఆన్ అయింది కాబట్టి దాని వోల్టేజ్ ఎలా ఉంటుంది? VB sat ఉంటుంది. వోల్టేజ్ ఎలా ఉంటుంది? VC1 is equal to, ఇది చేంజ్ చేయండి అమ్మా. VC1 is nothing but VC sat. VC sat VC2. Okay na? VC2 is equal to VCC, VB2 is equal to VB cutoff, VC1 is equal to VC sat. Means Q1 transfer on కాబట్టి voltage ఎలా ఉంటుంది? VB sat approximately 0. Now Q2 is off కాబట్టి collector voltage approximately equal to VCC. Because VCC ఉంది కాబట్టి అక్కడ voltage ఎలా ఉంటుంది? Cut off లో ఉంటుంది. VB2 is VB2 cut off. Now this is one state. Now I am to change the state. To change this state, stable state into another stable state, we are going to apply positive trigger pulse. Nee ipudu wave form చూపించేది పాజిటివ్ లో ఉంది కాబట్టి పాజిటివ్ చెప్తున్నాను. నెగిటివ్ కూడా అప్లై చేయొచ్చు. Where you can apply negative, I will explain later. Now apply positive going trigger pulse at base of the Q2 transistor. See here, come to this one. Previous game అనుకున్నాం. ఇప్పుడు now this one is on. I am assuming this one is on. Now state this one is on. This two is off. This off undi. Man ipudu present state this one is off. This one is off. Now I am going to apply positive trigger. Ekkada apply cheyalani positive trigger? I am going to apply positive trigger here because this already on. No need to apply it here. It is. You can apply base of the Q2. If you want to apply negative trigger pulse, you can apply here. ఏ ట్రాన్స్లేటర్ ఆన్ అయి ఉంటుందో that transistor should be off. That way you can apply negative. Which transistor is off? That transistor should be on. That base you can apply positive. Okay, that base is applied positive. Therefore here same I am assuming. Okay na? Same I am applying the base. Student, I am applying the positive going trigger pulse at the base of the Q2. Why? Because Q2 is off. Q2 off lo undi kabatti నేను base of the Q2 దగ్గర I am going to apply positive trigger pulse. Otherwise negative going trigger